Hello, this is Yanis from Any Repair. Today we'll go through a repair for a Vostro 153510 that came to our lab dead after a drop. Let's go and see how we will deal with it. This is the board. It is dropped and we must see what we can do about it. It is dead, of course, and let's have some measurements with diode mode. We prefer diode mode to check the coils. So, let's go and take some measurement as there are no schematics or board view for this board. We will go with ohm and assume an assumptions for checking this board. This coil is okay, but it must be 5 volts. These values are good. Under this plastic sheet there is a coil. It is good. No problem with that. Maybe something else here. Yes, it is. Let's check. It is a bit low or very low. Maybe this is something suspicious. Since it is far from the CPU, let's check down. The bottom of the board has no coils, so we will dare and plug the power supply. Oh, it is oh, the consumption is high. It is about half an amp while we're plugging the charger, so we will use our thermal camera in order to check what is heating. And we can see that here in the upper side of the board something is heated, but there's nothing there, so we'll go to the bottom side, and this is the Super IO. Yes, it is the Super IO. So we must replace this guy. It is very hot. I will not put any finger on it. I'm not well trained in army. So let's go under the microscope and remove this burn component. This burn component is not a normal Super IO. It is a dual array pins Super IO. It has these pins that are easy to see, but inside those pins are some other pins that should be soldered. You will see it. You will see it in the procedure. I'm removing the heatsink now to make things easier and not to melt any plastic sheets that are offering a minor but needed water resistance. We will remove the RAM too. And the plastic that holds this RAM on the slot. We will remove this layer, this plastic sheet. And with our heat gun, we will remove this Super IO and reveal what is under. That I was trying to tell you. So, heat gun and tweezer. it is not an easy thing to remove and replace this Super IO. I will use this sucker to vacuum this chip up. Now we will clean the old solder. You can already see that this Super IO has two arrays of pins that should be soldered. So consider this if you're trying to replace this Super IO. Flux, a wick, and soldering iron will do the job. We'll make these pads nice and flat. For the chip to be totally attached to the pads, on the pads. We're cleaning the solder the better way we can. And after that, and after a good isopropylic and cotton pad clean, we will try to align the new chip. So let's go and clean. That is better. We can view the pads. We can see the pads if there is any bridging. So what we must do now, we must check the coil that was having a low ohms resistance before and see if that was a feed for the Super IO. That was the coil. And now, as you can see, it's having a normal ohms resistance, voltage drop in diode mode we're measuring. So this PL301 was feeding this Super IO. It was normally having a low resistance because the Super IO was shorted. Now, with this done, we can flux and tin the pads in order to properly solder the new, this one, the new Super IO. This is not an easy job, as I said before, because there are pads that are hidden, and you will understand it in the process. So, let's go and flux this area and tin the pads. Fresh solder and soldering iron for the process to continue. Soldering the pads. And after that, we will prepare the chip too with flax and solder, fresh solder, in order to make the soldering easier. You will see it after that soldering, after that tinning. Our chip is not new. We have ordered, of course, new, but Chinese friends are not sending anything new. They are pulled from other boards and cleaned, but you can see the marks. So, tearing the pins of the Super IO, because it is a large IC, and in my opinion, must be tinned. Be careful not to burn our fingers. My fingers are burned, so I'm comfortable with that. It's not a good thing to place your fingers near a soldering iron with 350 Celsius. The tinning is done. We're doing some details, and after that, the alignment will begin. Let's go and solder this guy. We're trying to align. The align should be proper in order to properly solder the chip. We're using our hot air gun, and the heat that the IC absorbing is very high. And it is not, you can see that I will move the chip and move it again because I was careless. Now I will let it cool, and now it's okay. And after that, I will have a little pressure on it with my tweezers in order for the ground pad to be soldered properly and the rest of the pins to be soldered too. And I think we are ready. We will do some bridge cleaning. We'll clean the area around, and we will test the coil for shorting. After the cleaning, it is the time to test the coil. This coil was shorted the first place. Now we have soldered a new Super IO, and it is still having a very good ohms resistance, a very good voltage drop. We will remove the microscope from the overhead camera view and try and check this board. We will dare and plug the power supply, but first we will place the RAM. And for testing only, we will try to power on without heatsink. Check the voltage on the coil that was shorted. The on-screen multimeter is not working good, so I will reveal my multimeter, the overhead camera, for you to see the voltage. This is it. You can see that the voltage is proper on the coil. It's 3.3 volts. And now we're having 5 volts here. These coils cannot be triggered unless the notebook is powered on. I'm trying to find some other voltages like 1.8 and 1.05. I will place the board back on its chassis in order to power on and check for image. I think we will be good for it. We will plug the necessary cables. I think we're good to power it on. We'll plug the charger. And I think it is on. The fan is spinning, but not having a screen display because I have removed the display cable. I will put it back and check again. It is on. You can see that it's a broken screen, but after a while I think we will have a display. It is RAM training and it's okay now. You can see the broken screen, you can see the Dell logo, and I think we're good. We are okay to continue. That was the repair as you saw. If you liked this video, consider a like, subscribe and share. Thanks for watching. See you in another repair. Bye.